National Electrical Code Section 300.22 code addresses the protection of non-metallic sheath cable, commonly referred to as an N cable, when it passes through a veneer wall constructed of brick or block. The NEC mandates that any NM cable traversing such a wall must be safeguarded within an approved raceway or chase. This requirement exists to prevent physical damage to the cable, which could lead to electrical hazards. The reasoning behind this code provision stems from the inherent vulnerability of NM cable. While NM cable is suitable for many interior wiring applications, it is not designed to withstand the abrasive forces or potential impacts associated with being directly embedded within or exposed to the elements within a brick or block wall. The rough texture of brick and block, combined with potential moisture and settling, can gradually wear away the cable's outer jacket, exposing the conductors and creating a risk of short circuits, ground faults, and even fire. The purpose of a raceway or chase is to provide a protective conduit for the NM cable. A raceway is an enclosed channel designed specifically for holding wires, cables, or bus bars. Common types of raceways include electrical metallic tubing, often abbreviated as EMT, rigid metal conduit, or RMC, intermediate metal conduit, or IMC, and rigid polyvinyl chloride conduit, known as rigid PVC. A chase, on the other hand, is a channel or groove built into the wall specifically to accommodate wiring or piping. While a chase can sometimes be an open space, in the context of NEC Section 300.22 code, it is generally understood to require a degree of enclosure or protection similar to a raceway. The phrase approved raceway is significant because it implies that the raceway must meet specific standards and be listed by a recognized testing laboratory, such as Underwriters Laboratories, or AL. This listing ensures that the raceway is suitable for its intended purpose and provides a certain level of protection against physical damage, moisture, and other environmental factors. When selecting a raceway for this application, several factors should be considered. Firstly, the size of the raceway must be adequate to accommodate the NM cable or cables being installed. The NEC provides guidelines for conduit fill, which specify the maximum number of conductors or cables that can be installed in a particular size of raceway. Overfilling a raceway can make it difficult to pull the conductors or cables, and it can also lead to overheating due to restricted airflow. Secondly, the material of the raceway should be appropriate for the environment. For example, if the wall is exposed to moisture or corrosive substances, a non-metallic raceway, such as rigid PVC, may be a better choice than a metallic raceway. Thirdly, the raceway must be properly supported and secured. The NEC specifies requirements for supporting raceways to ensure that they do not sag or become dislodged. Support should be spaced at intervals that are appropriate for the type and size of raceway being used. The installation of the NM cable within the raceway should also be done carefully. The cable should be pulled smoothly and without excessive force to avoid damaging the conductors or the outer jacket. Lubricants may be used to reduce friction during the pulling process. Once the cable is in place, the ends of the raceway should be sealed to prevent moisture and debris from entering. This can be accomplished using conduit bushings or sealing fittings. In situations where a chase is used instead of a raceway, the chase should be constructed of durable materials and should provide adequate protection for the NM cable. The chase should be wide enough to accommodate the cable without crowding, and it should be deep enough to prevent the cable from being exposed to the surface of the wall. The chase should also be sealed at both ends to prevent moisture and debris from entering. It's important to recognize that NEC Section 300.22 code is just one of many code requirements that address the installation of NM cable. Other relevant sections of the NEC include Article 334, which covers the general requirements for NM cable, and Section 300.4, which addresses protection against physical damage. When working with electrical wiring, it is always essential to consult the latest edition of the NEC and to follow all applicable codes and regulations. In addition to the NEC requirements, local building codes may also impose additional restrictions or requirements on the installation of NM cable. It is important to check with the local building department to ensure that all applicable codes are being followed. When installing NM cable through a veneer wall, it is also important to consider the potential for future renovations or repairs. If the wall is likely to be modified in the future, it may be necessary to provide additional protection for the cable or to install it in a location where it will not be affected by the renovations. The use of an approved raceway or chase provides a degree of protection that can help to prevent damage to the cable during future construction activities. Furthermore, it is crucial to employ qualified and licensed electricians for electrical work. These professionals possess the requisite knowledge and expertise to ensure code-compliant and safe installations. Licensed electricians are familiar with the NEC and local building codes, and they have the training and experience to identify and address potential hazards. Attempting to perform electrical work without proper training can be dangerous and can lead to serious injury or even death. Electrical installations should be inspected by a qualified electrical inspector to ensure that they comply with all applicable codes and regulations. The electrical inspectors are trained to identify potential hazards and to ensure that electrical systems are installed safely and correctly. A thorough inspection can help to prevent electrical fires, shocks, and other hazards. In summary, when running NN cable through a veneer wall constructed of brick or block, adherence to NEC section 300.22 cone is paramount. This section mandates the protection of the cable within an approved raceway or chase to mitigate the risk of physical damage and potential electrical hazards. Choosing the correct raceway type, ensuring proper installation practices, and consulting with qualified professionals are essential steps to ensure a safe and compliant electrical installation. This detailed explanation covers the requirements and considerations for protecting an NM cable when passing through a veneer wall, as mandated by the National Electrical Code, specifically Section 300.22 cone. Remember to always consult the most recent version of the NEC and local codes for the most accurate and up-to-date information. Furthermore, working with electricity can be dangerous. Always hire a qualified and licensed electrician to perform electrical work. Their expertise ensures safety and code compliance. The approved raceway or chase should be large enough to accommodate the cable without stressing it, and it should be securely fastened to the wall to prevent movement or damage. Also, consider the aesthetic impact of the raceway or chase. While functionality is paramount, it's often possible to select a raceway or chase that blends in with the wall's appearance. In some cases, the raceway can be concealed within the wall, provided that it remains accessible for future maintenance or repairs. Accessibility is a key consideration in electrical installations. While NM cable can be concealed within walls, ceilings, and floors, it must remain accessible for inspection, maintenance, and repairs. This means that access panels or removable covers may be required in certain locations. It's also important to properly label all electrical circuits and components. This helps to prevent confusion and makes it easier to troubleshoot problems in the future. Circuit breakers and electrical panels should be clearly labeled to indicate which circuits they control. Proper labeling can save time and effort during maintenance and repairs, and it can also help to prevent electrical accidents. Grounding is another critical aspect of electrical safety. All electrical circuits and equipment must be properly grounded to provide a safe path for fault current to flow back to the source. Grounding helps to prevent electrical shocks and reduces the risk of fire. The NEC specifies detailed requirements for grounding electrical systems. Surge protection is also an important consideration, especially in areas that are prone to lightning strikes or power surges. Surge protectors can help to protect sensitive electronic equipment from damage caused by voltage spikes. Surge protectors are available in a variety of forms, including whole house surge protectors and plug-in surge protectors. Regular maintenance is essential for ensuring the safety and reliability of electrical systems. Electrical panels should be inspected periodically for signs of corrosion, damage, or overheating. Circuit breakers should be tested regularly to ensure that they are functioning properly. Wiring connections should be checked to ensure that they are tight and secure. Any damage to a worn electrical component should be replaced promptly. Finally, remember that electrical codes and regulations are constantly evolving. It's important to stay up to date on the latest changes to the NEC and local building codes. This can be accomplished by attending continuing education courses, subscribing to industry publications, and consulting with qualified electrical professionals. Staying informed about the latest codes and regulations helps to ensure that electrical installations are safe, compliant, and reliable. The use of proper tools is also essential for safe and effective electrical work. When working with electrical wiring, it's important to use insulated tools that are designed for the specific task. This helps to prevent electrical shocks and reduces the risk of injury. Common electrical tools include wire strippers, pliers, screwdrivers, and voltage testers. A voltage tester is an essential tool for any electrician. It can be used to verify that a circuit is energized before working on it. This helps to prevent electrical shocks and ensures that the work can be performed safely. Before working on any electrical circuit, it's important to turn off the power at the circuit breaker. This will de-energize the circuit and reduce the risk of electrical shock. It's also important to test the circuit with a voltage tester to verify that it is de-energized. Even after turning off the power at the circuit breaker, it's still possible for a circuit to be energized by a backfeed or other source of power. That's why it's so important to test the circuit with a voltage tester before working on it. If you're not comfortable working with electricity, it's best to hire a qualified and licensed electrician. The electrical work can be dangerous, and it's important to take all necessary precautions to prevent accidents. A qualified electrician has the training and experience to perform electrical work safely and effectively. The information provided here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Neglecting these precautions and guidelines can lead to hazardous situations, electrical shocks, fires, and potential property damage. Prioritizing safety, code compliance, and professional expertise is paramount when dealing with electrical systems.